dear students. So now we'll see what is the potential due to system of charges. So it is also the superposition principle, as you have seen in the first chapter, superposition principle for the system of charges. Here we are taking about the potential due to system of charges. So let us see what it will be. Yeah, so from the diagram or the figure you can see here, there is a center point P. At this point there are, away from that point there are number of charges, that is n number of charges, so like q1, q2, q3, q4, qn. So all are pointing towards at the point, the same point P, and the q1 from P, let us consider the charge q1 with the position vector r1, and q2 the position vector r2, and q3 position vector r3, and q4 position vector r4, and so on. So as it is a system of charges, there will be n number of charges, so hence we will take like qn, so it will be rn. So therefore the same thing I have written here. Let q1, q2, q3 so on be the n number of charges at r1, r2 and r3 and rn respectively from at the point P. So therefore we will take the individual potentials. So let us consider for the first potential, for the potential P due to the charge q1. So therefore we will have v1 equal to 1 by 4 pi epsilon naught q1 by r1. Then potential due to q2 is written as 1 by 4 pi epsilon naught q2 by r2, and so on. So similarly for v3 you can take it as 1 by 4 pi epsilon naught q3 by r3, and finally similarly we have taken for qn as vn equal to 1 by 4 pi epsilon naught qn by rn. Therefore here also we will apply the superposition principle. So that means the net potential at the same point, at the point P, is the sum of the potential due to the number of charges. Here you can see here V is the net potential, and it is equal to V1 plus V2 plus V3 and so on n Vn. So that is for n number of charges. So in the first chapter also you have seen the force due to number of charges. There also the net force at a point P due to n number of charges, you have F equal to, capital F equal to F1 plus F2 plus so on Fn. So in the same manner here also we are taking the superposition principle for the potential at a point due to n number of charges. So the same thing here also. Yeah. Then therefore we will write the potential as V equal to 1 by 4 pi epsilon naught summation I tending from 1 to n, therefore qi by ri. Then lastly what we get, the final answer is V equal to 1 by 4 pi epsilon naught q by r. So this is the potential due to n number of charges.